Find somewhere comfortable tonight. You don't need to follow any of this closely. You don't need to hold on to the details or remember the names or trace the journey from beginning to end. Just let the words come to you the way sound does when you're almost asleep. We're going back a long way tonight, 7 centuries, give or take, to a world that looked nothing like this one, and yet was made of the same things this one is made of. People waking in the morning, people eating bread, people worrying about small things and large things, people loving each other, people afraid of the dark. If today was hard for you, and maybe it was, in ways you haven't quite set down yet, then perhaps there's something quietly comforting in the knowledge that humans have always carried weight, that the capacity to endure is very old, older than any of us. We're in no hurry. The night is long and patient, and so is this story. Let it arrive at whatever pace it chooses. To understand what the Black Death did to the world, you have to first understand the world it entered, not as a collection of facts, but as a living place. A place with a smell and a sound and a particular quality of morning light. It is the mid-14th century. Somewhere in northern France or in the low valleys of Tuscany or along the grey harbours of the English coast, a town is waking up. The bells of the parish church ring for prime, the first hour of prayer just after dawn, and the sound moves through narrow streets where the houses lean toward each other overhead, their upper stories almost touching, blocking out the sky in thin strips. The cobblestones are wet. A baker has been at work since before midnight, and the smell of bread drifts through the quarter, warm and ordinary and good. Medieval European towns were intimate in a way that is difficult to picture now. The largest cities, Paris perhaps, or Florence or London, held populations in the tens of thousands, sometimes approaching 100,000 in the most prosperous decades of the early 14th century. A market town of 2,000 or 3,000 souls, a village of a few hundred. And in these places, everyone shared everything, the well at the centre of the square, the narrow alleyways where children ran and pigs wandered, the church where the week was organised around the rhythm of feast days and fast days, saints' days and harvest thanksgivings. The feudal system had organised European society for centuries by this point. At its simplest, it was an arrangement of obligations running in both directions. Peasants, called serfs in much of Europe, were bound to the land of a lord. They could not leave without permission. They owed their lord labour, typically several days a week working his fields before they could tend their own, as well as a portion of what they grew. In return, the lord owed them protection from rival lords, from bandits, from the general violence that could descend without warning on undefended people. It was not a gentle arrangement, and it was not an equal one, but it was a structure, and it had held for a long time. Above the lords were the great nobles and the kings, and threaded through all of it, touching every level of society, was the church. The Catholic Church in 14th century Europe was not simply a religious institution in the way we might think of one today. It was the organizing principle of time itself. The calendar was a church calendar. The hours of the day were church hours. Birth, marriage, and death were all church events, marked by sacraments that were understood to be not merely symbolic, but genuinely necessary for the soul's passage through this life and into the next. The church building was often the only stone structure for miles. When people were frightened, they went there. When they were grateful, they went there. When they needed to understand why something had happened, the church provided the framework. And yet this was also a world in motion. The image of medieval Europe as static and isolated is misleading. The trade networks of the mid-14th century were extraordinary in their reach. English wool moved south through Flanders, the region of modern Belgium and northern France, where the great weaving cities of Bruges and Ghent transformed raw fleece into cloth that was traded across the continent. Italian merchant houses, the great banking families of Florence and Genoa and Venice, had agents in London and Constantinople and Cairo. The Hanseatic League, a confederation of trading cities stretching from the Baltic coast down through northern Germany, moved timber and grain and salted fish in quantities that kept entire regions fed through winter. And then there was the Silk Road, not a single road, but a vast braided network of routes stretching from the Chinese coast westward through Central Asia, through the mountain passes of Persia and the deserts of the Middle East, to the ports of the Eastern Mediterranean. Along this network moved silk and spices, glass and paper, ideas and diseases. The great caravanserais, the roadside inns of the eastern routes, some of them enormous, able to shelter hundreds of merchants and thousands of animals, were places where a Venetian trader might sleep under the same roof as a Mongol herder, where goods changed hands across vast cultural distances, where the world was, in its slow and laborious way, connected. The port of Messina, on the northeastern tip of Sicily, was one of the hinge points of this connected world. Sicily sat at the center of the Mediterranean, and Messina in particular faced the narrow strait between the island and the Italian mainland. Ships from the east unloaded here. Grain from the Black Sea coast, spices from further still, silks and dyes and all the movable wealth of the eastern trade. The harbour was busy and loud and salt-smelling, full of the shouts of dockworkers and the creak of rope and timber. It was one of the great thresholds of the medieval world, a place where east became west, where goods from thousands of miles away arrived and dispersed into the veins of European commerce. In 1346, none of this felt precarious to the people living inside it. Life was hard. It was always hard, but it was familiar. The harvest had been difficult in recent years. The early 14th century had brought a period of cooling weather and wet summers that historians now call the Little Ice Age, and the Great Famine of 1315 to 1322 had already killed millions across northern Europe, a wound the continent was still slowly healing from. But by the mid-1340s, things had stabilized, markets were busy, the wool trade was moving, the great cathedrals of France and England were still being raised, stone by stone, toward the sky. Imagine a single day in the autumn of 1346. A woman in a village outside Siena rises before dawn to start the fire. Her husband has already gone to the Lord's field. Her children sleep in the same room, under rough wool blankets. She will bake bread today, carry water from the shared well in the square, say a prayer at the small shrine in the corner of the room where a painted wooden figure of the Virgin stands. The bells will ring again at terce, at sext, at none, marking the day's passage in intervals of prayer. In the evening her husband will come home. They will eat together. The children will run in the street until the light fails. The priest will ring compline, and the village will grow quiet. It was a life entirely contained within a few miles, a life in which the largest thing was the church, and the most immediate thing was the weather and the harvest. A life in which news from the east, if it arrived at all, arrived months late and filtered through so many retellings that it bore little resemblance to what had actually happened. Somewhere to the east, along the trade routes that connected this woman's world to places she had no name for, something was already moving. It had been moving for years. It was moving through the mountain passes and across the steppes, following the same paths the silk and the spices followed, carried in a way no one yet understood, toward the harbour at Messina and the open gates of a world that had no idea it was coming. The bread was baking, the bells were ringing, the children were running through the narrow streets. The story of how the Black Death reached Europe begins with a cemetery in the mountains of Central Asia, and with a discovery made not in the 14th century but in our own time. In 2022, a team of researchers, including scientists from the Max Planck Institute for Evolutionary Anthropology and the University of Stirling, published findings in the journal Nature that placed the pandemic's origin with a precision that would have seemed impossible even a decade earlier. They had analyzed ancient DNA recovered from graves in the Kara-Jigach region of what is now Kyrgyzstan, high in the mountains to the east of the Caspian Sea. The tombstones above these graves were dated 1338 and 1339. And in the teeth of the people buried there, teeth being among the best preservers of ancient biological material, sealed and protected for centuries, researchers found the DNA of Yersinia pestis. Not just any strain. The strain they found was a direct ancestor of the one that would go on to kill a third of Europe. The genetic evidence pointed to this region, at this moment, as the place where the pandemic began its westward journey. 19 years before those first ships arrived in Messina. That gap, nearly 2 decades between the earliest graves in Kyrgyzstan and the first European deaths, tells us something important about the pace at which the disease moved through its animal reservoirs before it found its way into human trade networks in sufficient force to travel west. Yersinia pestis is not primarily a human disease. It is a disease of small mammals, marmots, gerbils, voles, the various rodents that live in the grasslands and mountain foothills of Central Asia. In those populations, it had existed for a very long time, cycling through animal communities in ways that rarely touched humans. What happened in the late 1330s in the mountains of what is now Kyrgyzstan was some kind of disruption, ecological, climatic, or simply probabilistic, that brought the bacterium into contact with human communities in a new way. The Mongol Empire, at its height in the previous century, had created the conditions for exactly this kind of transmission. The Pax Mongolica, the relative peace that the Mongol rulers imposed across their vast territory, had opened the Silk Road to traffic on a scale not seen before. Merchants, soldiers and animals moved across the steppes in numbers that would have been unimaginable a century earlier, and with them inevitably moved the rats. The black rat in particular, smaller and more agile than its brown cousin, comfortable living in cargo holds and grain stores, was the primary reservoir for the fleas that carried Yersinia pestis. Where the trade goods went, the rats went. Where the rats went, the fleas went. Where the fleas went, the bacterium went. From Kyrgyzstan, the disease moved west along the Silk Road, through the Mongol-controlled steppes of southern Russia, through the trading cities of the Caucasus, into the Crimea, that triangular peninsula jutting into the Black Sea, where the Genoese, the great maritime trading power of the age, maintained a colony at the city of Kaffa. Kaffa was an enormously important port. It was one of the main western terminals of the Silk Road, the place where goods from the east were loaded onto ships bound for the Mediterranean. Around 1346, the plague arrived at Kaffa. The circumstances of its arrival there have become one of the most discussed episodes in the history of disease because the city was at the time under siege by a Mongol army, the forces of the Golden Horde, led by a Khan named Janibeg. And according to a contemporary account by a Genoese lawyer named Gabriele de Mussi, when plague broke out in the besieging army, Janibeg ordered the corpses of the dead to be loaded onto catapults and hurled over the walls of the city into the streets of the Genoese defenders. Whether or not this account is entirely accurate, and historians debate its details, what is clear is that plague reached the inhabitants of Kaffa, and that the Genoese merchants who fled the city by ship carried it with them. Those ships sailed west. They stopped at Constantinople, already one of the great cities of the world, where the disease spread with speed. They passed through the Greek islands, and in October of 1347, a fleet of Genoese trading ships entered the harbour at Messina, Sicily, the harbour that we stood in together at the end of the last chapter. The harbour that was busy and loud and salt-smelling and full of the ordinary noise of commerce. The dockworkers who approached those ships found something that stopped them. The crews were dying. Some were already dead. Those still alive were covered in strange swellings, dark, oozing masses in the armpits and groin, the size of eggs. The Messina authorities reacted quickly. They ordered the ships out of the harbour, but it was already too late. The disease had stepped ashore. Now, a detail worth sitting with for a moment. The mechanism by which a bacterium travels from the mountains of Kyrgyzstan to the harbor of Sicily is not mysterious in principle, but it is remarkable in its specificity. Yersinia pestis lives in the gut of a flea. The flea, in this case most commonly a species called Xenopsilla chaopis, the oriental rat flea, feeds on the blood of rodents, particularly black rats. When a flea feeds on an infected rat, it ingests blood containing the bacteria. The bacteria then multiply inside the flea's gut, eventually forming a blockage, a dense mass of bacterial cells that obstructs the flea's digestive tract. When the flea tries to feed again, it cannot swallow properly. It draws blood from its host, then regurgitates it back, along with a bolus of bacteria, into the bite wound. This is the moment of transmission. The flea, in its hunger, becomes an unwitting syringe. The rat carrying the infected flea lives in the cargo hold of a trading ship. The ship crosses the Black Sea. The rat dies. Plague kills rats too, and the flea, now without a warm host, moves. It climbs. It finds the nearest available warm body. In the confines of a ship, that body is human. A 2025 study introduced another layer to this picture. Researchers analyzing climate data from tree rings and ice cores, those remarkable natural archives that record the temperature and atmospheric conditions of past centuries in their annual growth layers, identified evidence of a major volcanic eruption in the years just before the pandemic reached Europe. A large eruption injects sulfur dioxide into the upper atmosphere, where it forms a reflective haze that reduces the amount of sunlight reaching the surface. The result is a period of cooler temperatures and disrupted rainfall patterns. Crop failures follow. And crop failures, in the 14th century, meant that the Italian city-states, which had been largely self-sufficient in grain, were suddenly forced to import it. From the Black Sea coast, from exactly the region where the plague was already spreading. The grain ships that came to feed a hungry population may have brought something else along in their holds. Climate and commerce, hunger and trade, a flea the size of a sesame seed, carrying something invisible inside it, riding a rat, riding a ship, crossing a sea. The gates of Messina stood open, the ships came in, and the world that had been moving at the pace of ox carts and sailing vessels for centuries was about to change faster than anyone inside it could comprehend. There is something almost meditative about trying to understand Yersinia pestis at the level of what it actually is, not what it caused, not what it meant, but what it physically is, moving through a body, doing what it does. It is a bacterium, a single-celled organism, neither plant nor animal, but something older than both. Under a microscope, it looks like a tiny rod, or sometimes a rounded rod, what biologists call a coccobacillus. It measures somewhere between 0.5 micrometer and 2 micrometers in length. To give you a sense of that scale, a human hair is roughly 70 micrometers across. You could line up 35 Yersinia pestis bacteria, end to end, across the width of a single strand of your hair. It is, in other words, extraordinarily small. And yet in sufficient numbers, acting with the particular biological machinery it carries, it was capable of killing half the people it touched. The bacterium has an outer membrane, a lipopolysaccharide layer, meaning a structure made of fat molecules bonded to sugar chains that serves as both a physical barrier and a kind of molecular disguise. This outer layer is one of the first things the human immune system encounters when bacteria enter the body, and it is one of the first things that Yersinia pestis uses to its advantage. Here is how the encounter between the bacterium and the human body unfolds, step by step. The flea bites. The bacteria enter the skin, deposited into the small wound by the flea's regurgitation. The numbers at this stage are relatively modest, perhaps a few hundred to a few thousand bacterial cells. The body's first line of response is its immune patrol, cells called macrophages, which circulate through the tissues, constantly sampling their environment, engulfing and destroying anything that looks foreign. Macrophage is a Greek-derived word meaning, roughly, big eater, and that is what they do. When a macrophage encounters a bacterium, it flows around it, engulfs it, and then attempts to destroy it using the combination of acidic enzymes and chemically reactive molecules, the biological equivalent of dissolving something in acid. For almost every bacterium that exists, this process works. The macrophage wins. The infection is contained before it begins. Yersinia pestis has evolved a way around this. When a macrophage engulfs a Yersinia pestis cell, the bacterium does not die. It survives inside the macrophage's digestive compartment. It has proteins that neutralize the acid. It has other proteins that prevent the macrophage from signaling to the rest of the immune system that something is wrong. It is, in effect, hiding inside the very cell that was supposed to kill it, and while it hides, it replicates. This is the critical trick, and it is worth understanding why it works. The macrophage, after engulfing what it believes to be a contained threat, does what macrophages do. It migrates. It moves through the lymphatic system, the network of fine vessels that drains fluid from the tissues and returns it to the bloodstream, carrying its apparently neutralized cargo toward the nearest lymph node. Lymph nodes are the immune system's processing centers, dense clusters of immune cells where the body evaluates threats and mounts coordinated responses. They sit in the armpits, in the groin, in the neck, at the junction points of the lymphatic network. And this is exactly where Yersinia pestis wants to go. By the time the macrophage arrives at a lymph node, the bacteria inside it have already begun to multiply. They burst out of the macrophage. They are now in an environment absolutely packed with immune cells, but they have spent the journey acquiring something important: time. Time to switch on the full suite of their virulence machinery. Virulence factors, the proteins and molecular tools that make a pathogen dangerous, are the mechanisms by which bacteria overcome the body's defenses, and Yersinia pestis carries an impressive array of them. Some of these tools work by suppressing the immune system's ability to communicate. Normally, when immune cells detect an invader, they release small signaling proteins called cytokines, chemical messages that alert neighboring cells to the threat and coordinate a response. Yersinia pestis produces proteins that interfere with this signaling. The immune cells in the lymph node are present, but they are partially blinded, unable to mount the full coordinated response they normally would. Other virulence factors work more directly. The bacterium carries a small additional loop of DNA called a plasmid that encodes a protein capable of disabling the neutrophils, another class of immune cell that would normally be recruited to fight the infection. It also produces a toxin that interferes with the normal cell death pathways that the body uses to sacrifice infected cells before the bacteria inside them can spread further. The result of all this is that the lymph node becomes a site of runaway bacterial replication. The node swells. It fills with bacteria, with dying immune cells, with fluid and inflammatory debris. It can expand from its normal size, perhaps a centimeter across, to something resembling a small plum, pressing against the surrounding tissue, exquisitely painful to the touch. This is the bubo, the hallmark of bubonic plague. Its name comes from the Greek word for groin, because the groin lymph nodes, draining the legs where flea bites most commonly occurred, were among the most frequently affected. But buboes could appear in the armpit or the neck as well, depending on where the flea had bitten. Bubonic plague, if the body cannot contain it at this stage, progresses. The bacteria breach the lymph node's boundaries and enter the bloodstream. This transition from lymphatic infection to blood infection marks the shift to what is called septicemic plague, and it is here that the disease becomes most immediately life-threatening. Bacteria circulating in the blood trigger a systemic inflammatory response. The body's immune system, finally recognizing the scale of the invasion, releases an enormous flood of cytokines. This flood, sometimes called a cytokine storm, causes widespread inflammation throughout the body. Blood vessels become leaky. Blood vessels become leaky. Blood pressure drops. Organs begin to fail. The blackening of the skin that gave the pandemic one of its names, the Black Death, is a consequence of this vascular collapse. When blood vessels in the extremities fail, the tissue beyond them dies from lack of oxygen. The fingers, the toes, the nose, the ears, these are the furthest points from the heart, the last to be perfused when circulation fails. The dead tissue darkens. It is a form of gangrene, visible on the outside, signaling what is happening on the inside. And then there is pneumonic plague. This is the form that occurs when the bacteria reach the lungs, either because septicemic infection has seeded the lungs from the bloodstream or because someone has inhaled bacteria-laden droplets directly from a coughing infected person. In the lungs, Yersinia pestis replicates rapidly in the wet, warm, oxygen-rich environment. The lungs fill with fluid and inflammatory material. Breathing becomes difficult, then labored, then impossible. And every cough expels a mist of bacteria containing droplets into the air around the sick person, capable of infecting anyone nearby without any flea or rat required at all. This is why pneumonic plague is the form that spreads most rapidly between people. It removes the flea from the equation entirely. It turns the act of breathing in a crowded space, a home, a church, a market, into a route of transmission. The incubation period for bubonic plague, from the moment of infection to the first symptoms, is typically between 2 and 8 days. For pneumonic plague, it can be as short as a single day. The body does not have long to mount its defense before the bacteria have already established themselves. And once the bacteria are established, once they are replicating inside macrophages, suppressing immune signaling, flooding the lymph nodes, the body is fighting a battle on ground that has already been partly conceded. What is extraordinary, and what researchers are still working to fully understand, is why the Black Death killed at rates so much higher than modern plague outbreaks. Today, bubonic plague untreated has a mortality rate somewhere between 30 and 60%. Pneumonic plague untreated is nearly always fatal, but the 14th century pandemic killed perhaps 40 to 70% of the people it reached in some regions, numbers that even modern untreated plague does not quite explain. Part of the answer may lie in the simultaneous presence of all three forms. Part may lie in the nutritional status of a population already weakened by years of harvest failures, and part, as we will explore later, may lie in the question of which transmission routes were most active and whether the fleas on rats were the only vectors carrying the disease through those crowded medieval streets. For now, though, let the image rest. A rod-shaped cell, half a micrometer wide, hiding inside the very cell sent to destroy it, riding the body's own transport system toward the place where the immune response is organized. It is almost elegant, in the cold, indifferent way that evolution produces elegance. Not designed, not intentional, just the accumulated result of millions of years of a bacterium and the immune systems of mammals pressing against each other, each shaping the other, until this particular set of tools was the one that survived. The science tells us what happened inside the body. But there were people inside those bodies, and their experience of this illness was something no diagram can fully hold. Giovanni Boccaccio was a Florentine writer, already at work on what would become the Decameron, a collection of stories told by a group of young people who have retreated to a villa outside Florence to escape the plague. He was in Florence when the Black Death arrived in 1348, and he wrote about what he saw with a clarity that has kept his account alive for nearly 7 centuries. He described the buboes. They appeared first in the groin or armpit, he wrote, and some grew to the size of an ordinary apple, others to the size of an egg, some larger still, some smaller. They were called gavocchioli, a word that sounds almost soft, almost gentle, for something so agonizing. After the buboes came dark blotches on the skin, appearing on the arms and thighs and across the body, a sign that the disease had moved into the blood. And then, usually within 3 days of the first symptoms, death. 3 days. From the first fever to the end. Agnolo di Tura was a chronicler in Siena, a city that lost perhaps half its population in the summer of 1348. He wrote, in words that have been quoted many times because nothing else quite captures what he was describing, that he buried his 5 children with his own hands. He could find no one else to do it. So many were dying, he wrote, that men believed it was the end of the world, not as a figure of speech, as a literal belief. The framework within which medieval people understood existence, a framework in which God ordered everything, in which suffering had meaning, in which the church mediated between human life and divine purpose, had no adequate response to what was happening. The priests were dying alongside their congregations. The sacraments were going unperformed. People were dying unshriven, without the last rites that Catholic theology held to be necessary for the soul's passage to heaven, and the Church had no answer for why this was being permitted. What did it feel like to fall ill? The earliest symptoms were easy to dismiss. A headache, a fever that came on quickly, the body's temperature rising sharply, driven by the immune system's first response to the bacterial invasion. Muscle aches, a general heaviness, a sense of something wrong that was not yet localized. In the first day, a person might have hoped it was simply a winter chill, a bad night's sleep, the ordinary ailments of a body working hard in difficult conditions. Then the swelling came. The lymph nodes, filling with bacteria and inflammatory fluid, became painful before they became visible, a tenderness in the groin or under the arm or at the side of the neck. Then the swelling itself, rising under the skin, hard and hot to the touch, exquisitely sensitive. The bubo could grow from its first appearance to the size of a large egg or a small apple in the space of a day or two. The pain was described in contemporary accounts as unbearable. People could not lie still. They could not find a position that gave relief. The fever climbed. The mind, deprived of sleep, began to wander. In cases where the bacteria broke through into the bloodstream, the transition to what we now call septicemic plague, the dark patches appeared on the skin. The medieval word for them was sometimes lenticulae, from the Latin for lentils, because of their shape and color. They spread across the arms and the chest. The extremities began to cool as circulation failed. The body was fighting on too many fronts at once, and it was losing. Medieval medicine looked at all of this and reached for the best explanatory framework it had. That framework was miasma theory. The word miasma comes from the Greek for pollution or contamination, and the theory held that disease arose from bad air, specifically the air that rose from rotting organic matter, from swamps and open sewers, from the decomposing bodies of animals and humans. The air itself, in this view, was the carrier. Breathing polluted air was how you got sick. It is tempting from a modern perspective to find this belief simply wrong and move on, but it is worth pausing on why miasma theory made sense and why it was not an unreasonable conclusion from the evidence available to people who had no microscopes, no knowledge of bacteria, no concept of germ theory. In a world where disease clustered in places with poor sanitation, and it did, for reasons we now understand, but they did not, the correlation between bad smells and sickness was real and consistent. Plague did spread through crowded, unsanitary environments. Physicians in the 14th century, working within this framework, recommended burning aromatic herbs, rosemary, juniper, laurel, to purify the air. They recommended avoiding low-lying areas where miasmas were thought to gather. They recommended that people not sleep facing the wind from the south, which was believed to carry disease. Some recommended bleeding the patient, drawing blood from a vein, on the theory that the corrupted humours responsible for the illness could be drained away. The 4 humours, blood, phlegm, yellow bile, and black bile were the organizing principle of medieval medicine inherited from ancient Greek physicians, and an excess or imbalance of any of them was understood to be the root of illness. Plague, with its fever and its dark swellings, was associated with an excess of corrupted black bile. Astrology played a role too. A conjunction of Saturn, Jupiter, and Mars in the sign of Aquarius in 1345 was identified by a commission of physicians at the University of Paris, convened by the French king to explain the pestilence as the probable celestial cause of the epidemic. The planets, in medieval cosmology, influenced the air and the humours. A malign conjunction could corrupt the atmosphere across entire regions. None of this helped. But it is important to understand that these were not foolish people grasping at nonsense. They were educated people applying the most sophisticated framework available to them to a phenomenon that lay entirely outside that framework's explanatory power. The bacterium was invisible. The flea was overlooked. The rat was simply part of the landscape. What they could observe was that people near the sick became sick, that the disease spread from place to place along routes of travel, that the air in plague-affected cities smelled different, because of the mass of unburied dead, because of the herbs burning in every doorway. Their observations were accurate, their conclusions were understandable, and they were helpless. What is perhaps most haunting about the accounts of plague illness in the 14th century is not the physical suffering, though that was real and extreme, but the social dissolution that accompanied it. The most intimate bonds of medieval social life, the bonds that were supposed to hold even in the worst circumstances because they were bonds of love and duty and Christian obligation, were severed by the simple animal fear of the disease. A sick person in a plague-struck town might find themselves alone in the house. The neighbors would not come. The family had fled or was already dead. The priest might come to the door but would not enter. Food might be left on the doorstep, a small mercy, but the person who left it would not stay. The silence in those houses, where there had been voices, was a particular kind of suffering that the physical symptoms alone cannot account for. Agnolo di Tura buried his children with his own hands. That sentence carries something that no clinical description can. The weight of it is not in the dying, which was everywhere. It is in the aloneness of the act, in the fact that there was no one else. A catastrophe of this scale does not arrive without provoking a response. Humans are inventive in crisis. They are also, in crisis, capable of both great tenderness and great cruelty, sometimes within the same community, sometimes within the same person. The Italian city-states were the first in Europe to face the full force of the epidemic, and they were the first to begin developing institutional responses. What they created, under enormous pressure, in the middle of a disaster they did not fully understand, were the earliest formal public health measures in European history, some of which we still recognize today. The city of Ragusa, on the Adriatic coast of what is now Croatia and known today as Dubrovnik, issued an order in July of 1377 that stands as one of the founding documents of modern public health. Ships arriving from plague-affected regions were required to anchor offshore for 30 days before anyone was permitted to disembark. 30 days was the original period, chosen because it corresponded to a period of waiting long enough to reveal whether any aboard were carrying the illness. The order was later extended to 40 days, 40 giorni in Italian, from the word quaranta, meaning 40. From this, the word quarantine entered the language, and the concept entered the practice of medicine, where it has remained ever since. Venice, which maintained perhaps the most sophisticated administrative apparatus of any medieval city, established a permanent magistracy for public health. The Provveditori alla Sanità, that had the authority to inspect ships, isolate the sick, and close the city's gates to travellers from affected areas. They established lazarettos, isolation hospitals built on small islands in the lagoon, far enough from the city that the sick could be cared for without infecting others. The first permanent lazaretto was established on an island called Lazaretto Vecchio in 1423, but the principle of isolating the ill on separate islands was already in practice during the first waves of the Black Death decades earlier. These were genuinely remarkable innovations. They did not arise from a correct understanding of how the disease spread. The authorities still believed in miasma, still lit bonfires in the streets to purify the air, but they emerged from the observation that proximity to the sick increased the risk of becoming sick, and that separating the ill from the well and slowing the movement of people from affected areas seemed to slow the disease's progress. The mechanism was wrong. The intervention was right. Not all responses to the plague were so measured. Across Central Europe, beginning in 1348 and intensifying through 1349, a movement arose that expressed the terror and the spiritual disorientation of the age in a very different way. Groups of men, sometimes dozens, sometimes hundreds, began traveling from town to town, moving in processions through the streets, flagellating themselves with leather straps studded with iron spikes. They beat themselves on the back and shoulders, drawing blood, chanting hymns, performing their suffering publicly as an act of collective penance. These were the flagellants, and at the height of the movement they were moving through Germany, the Low Countries, and parts of France in numbers large enough to alarm both civil and church authorities. The theology behind the movement was straightforward, even if the practice was extreme. The plague, in the flagellant view, was divine punishment for human sin. God was angry with humanity, and the disease was the instrument of his anger. If the plague could be explained as punishment, then perhaps it could be appeased, not by medicine, which was clearly failing, and not by prayer alone, which also seemed to be failing, but by suffering voluntarily undertaken. If the people themselves could demonstrate their penitence vividly enough, perhaps God's anger would be satisfied and the killing would stop. The church, which might have been expected to endorse this kind of public penance, was in fact alarmed by it. The flagellant movement operated outside church authority. The flagellants heard confession from each other, performed rituals that were supposed to be the exclusive province of ordained priests, and began to develop theology that verged on heresy. Pope Clement VI, sheltering in Avignon, which the papacy had relocated to in 1309, issued a papal bull condemning the movement in 1349, and it gradually faded. But its existence tells us something important about the psychological state of a society watching itself die and finding no adequate explanation. Fear, when it cannot find its true object, finds another one. And in 14th century Europe, the object it found with devastating frequency was the Jewish community. The accusation that spread through Germany and France and the Rhineland in 1348 and 1349 was that Jews had poisoned the wells, that the plague was not divine punishment or miasma or celestial conjunction, but deliberate human malice perpetrated by a community that was already viewed with suspicion and hostility by much of Christian Europe. Jews were dying of plague alongside their Christian neighbors. Pope Clement VI pointed this out in a papal bull issued in 1348, noting that the plague was killing Jews in regions where no Christians lived at all, which rather undermined the poisoning hypothesis. He explicitly condemned the attacks on Jewish communities and called on Christians to protect them. It made little difference. In Strasbourg, in February of 1349, approximately 2,000 Jewish people were burned alive. In Mainz, in August of the same year, the Jewish community, which had attempted to defend itself, was overwhelmed and killed. In Cologne, in Erfurt, in Basel, in hundreds of towns across the German-speaking lands, communities that had existed for generations were destroyed in a matter of months. Some Jewish communities, anticipating the violence, fled eastward into Poland and Lithuania, whose rulers offered them protection, a migration that would shape the geography of European Jewish life for centuries. The persecution of Jewish communities during the Black Death is one of the darkest currents in the history of the pandemic. It is also one of the most human, in the worst sense of that word, the way that catastrophe, when it exceeds understanding, bends fear into cruelty, and cruelty finds the nearest available target. And yet, against all of this, against the flagellants and the persecution and the abandoned houses and the death carts moving through the streets at night, there were other things happening too, quieter things. Things that do not make it into the chronicles as often, because they are not as dramatic, but that are perhaps more representative of what most people actually did. The gravediggers kept working. In city after city, the ordinary labour of burial continued, performed by people who knew perfectly well what they were risking. Some were paid. Wages for grave digging rose steeply during the plague years, because the work was dangerous and the demand was enormous. Some were prisoners offered remission of their sentences. Some were simply people who understood that the dead needed burying and that someone had to do it. Priests stayed in plague-struck parishes. Not all of them, many fled, and the church's reputation suffered for it, but many did. They sat with the dying. They performed what rites they could. They wrote letters to the families of the dead when they could find words. Neighbours left bread on doorsteps. This is such a small thing, and it appears in accounts from multiple cities. The practice of leaving food at the door of a house where someone was ill, knocking and stepping back, not entering, but not leaving the person entirely alone either. The distance that fear imposed, and the connection that something, call it conscience, or love, or simply the habit of being human, maintained across that distance. These gestures did not stop the plague, they did not even slow it, but they held something together in the middle of the dissolution, some thread of the social fabric, thin and frayed, but not entirely broken. The death carts moved through the streets, and the bread was left on the doorstep. Both things were true at once, and perhaps that is the most honest picture of what it was to live through those years. Numbers have a way of becoming abstract very quickly. 30 to 60% of Europe's population, 25 to 50 million people. The mind, encountering figures like these, does something protective. It processes them as statistics rather than as people, as a quantity rather than as a loss. So let us try to make the numbers smaller and see if they become more real. Imagine a village of 400 people. A typical English village of the mid-14th century, set in a river valley with a mill and a church and a market cross, and the fields radiating outward in the open field system that organized agricultural life across most of northern Europe. The fields are divided into long strips, and each family farms a scattering of strips in each of the 3 great fields that surround the village, so that good land and poor land are shared more or less equally. The mill grinds grain for the whole community. The blacksmith, the carpenter, the woman who knows about herbs and childbirth. There is one of each, maybe 2, and the village depends on all of them. Now remove 200 of those 400 people. Remove them not gradually, not across a generation, but within the space of a single summer. Some of the strips in the fields go unplanted. The harvest that is gathered is smaller than the village needs, because there are not enough hands to bring it in before the autumn rains come. The mill still stands, but the miller is dead and his apprentice, and no one else knows exactly how the millstone is dressed. The priest is gone. The blacksmith is gone. Families that have farmed the same strips for 5 generations have simply ended. No children, no cousins, no one to inherit. What happens to a village like this? Sometimes it recovers slowly, over years, as people move in from other places to fill the empty strips, as children grow up to take on the trades their parents practiced. But sometimes it does not recover. The historians of medieval England have catalogued what they call deserted medieval villages, settlements that were abandoned during or after the Black Death and never reoccupied. Their outlines are still visible in some English fields, the slight ridges and depressions where the house platform stood, the faint trace of the street, the hollow where the pond was. The grass grows over them, and the sheep graze there now, and the village is gone as completely as if it had never been. Across Europe, the scale of this kind of loss was repeated in thousands of places. Germany lost perhaps a third of its population, France perhaps half, England somewhere between a third and a half. In some regions of Italy, the mortality was higher still. Siena, Florence, Venice, cities that were densely packed and deeply connected to the trade routes that carried the disease, lost between half and two-thirds of their people in a matter of months. And then something strange happened, or rather, something slow and structural began to happen in the way that large historical changes always do, not as a single event, but as the accumulated consequence of millions of small adjustments stretching across decades. Labor became scarce. This is the most elementary economic fact of the post-plague world, and its implications were enormous. In the feudal system, the lord's power over the peasant rested partly on the surplus of labor. If a serf ran away, or refused to work, or demanded better terms, the lord could find another serf to replace them. There were always more people than land, more workers than work. The plague reversed this. Suddenly there were more farms than farmers, more lords than there were peasants to work their estates, and the peasants, for the first time in generations, had leverage. They used it. Across England, France, and Germany, the years after the Black Death saw peasants demanding wages for work that had previously been performed as feudal obligation, demanding the freedom to move from one lord's estate to another in search of better terms, demanding the right to rent land rather than being bound to it. The lords resisted. English lords pushed through the Statute of Labourers in 1351, which attempted to fix wages at pre-plague levels and prevent workers from leaving their home parishes. It was largely ineffective. The market forces created by the demographic collapse were stronger than legislation. The feudal system did not collapse overnight. It lingered in various forms for another century and more in England and considerably longer in parts of Eastern Europe. But the Black Death broke something in its foundations that never entirely healed. The assumption that peasants were a fixed resource, bound to the land, available to be exploited at a fixed cost, was shattered by the simple fact that half of them were dead. The church underwent a different kind of transformation, slower and more subtle, but perhaps even more consequential in the long run. The institution that had organized European spiritual life for centuries had offered no protection against the plague and, in the eyes of many, no adequate explanation for it. The priests had died. The prayers had gone unanswered. The sacraments had been administered too late or not at all. The Pope in Avignon had survived, but his survival, in contrast to the deaths of so many ordinary clergy, was not a comfortable image for an institution that preached the equality of souls before God. This did not destroy the church, but it introduced a crack in its unquestioned authority. People began to ask, quietly at first, whether the church's claim to mediate between humanity and God was as secure as it had seemed, whether the elaborate institutional structure of bishops and cardinals and papal legates was truly necessary, or whether the relationship between a person and God might be more direct than all of that. These are questions that would not find their full expression for another century and a half in the Protestant Reformation. But the seeds of that questioning were planted in the plague years, in the silence of churches where the priest had died and no one had come to replace him. The arts responded to the plague in ways that are still visible. The danse macabre, the dance of death, became one of the dominant artistic motifs of the late 14th and 15th centuries. It appeared in paintings, in woodcuts, in stone carvings on the walls of churches, a procession in which death, depicted as a skeleton, takes the hands of people from every station of life, pope and emperor, knight and merchant, peasant and child, and leads them in a dance toward the grave. The message was explicit and deliberate. No rank, no wealth, no piety had protected anyone. Death was the great equalizer, and it was not distant or abstract, but immediate and personal, dancing alongside you. This was a new note in European art. The death imagery of the pre-plague period tended to be formal and theological. The Last Judgment, the weighing of souls, the orderly procession of the saved and the damned. The Danse Macabre was something different. It was intimate. It was almost humorous in its grimness, death reaching out a bony hand to a fat merchant who would rather stay at his counting table, or to a king who cannot quite believe that his crown means nothing here. It was art that had looked directly at what had happened and refused to look away. Europe's population would not return to its pre-plague levels for roughly 200 years, 2 centuries of demographic shadow, 2 centuries in which the continent's labor force, its agricultural capacity, its urban populations were all operating below the level they had reached before 1347. 200 years is longer than the entire span of modern American history. It is longer than the distance between Shakespeare and us. For 200 years, the Black Death's shadow lay across European society, shaping everything from the price of bread to the architecture of churches to the slow transformation of the relationship between lord and peasant that would eventually produce the modern world. The numbers, then, are not really about numbers at all. They are about the particular shape of a world that was remade, slowly and painfully, in the aftermath of an event that no one had prepared for and no one fully understood. Here is something remarkable, something that connects the 14th century to the body you are lying in right now, tonight, in this quiet room. The people who survived the Black Death were not simply lucky, some of them were. Luck is always part of it. Who was bitten by the flea and who was not, who sat next to the sick person in church and who happened to be elsewhere that day. But for a significant portion of the survivors, there was something else at work, something in their biology that gave them an edge, a slightly better chance of fighting off the bacterium even when it had entered their body and begun its work. And because they survived, they had children. And the biological advantage that had helped them survive was passed down through the generations, written into the DNA of their descendants, which may include you. In October of 2022, a study was published in the journal Nature that offered the most detailed picture yet of this process. The research was carried out by teams from the University of Chicago, McMaster University in Canada, and the Institut Pasteur in Paris. Institutions on 3 continents working together on a question that touched all of them. What they did was analyze ancient DNA extracted from the remains of more than 200 individuals buried in London and in Denmark, in cemeteries that spanned the period before, during, and after the Black Death. They were looking for genetic variants, small differences in the DNA sequence, that appeared at different frequencies in the pre-plague and post-plague populations. If a variant became significantly more common after the pandemic, that was evidence that people carrying it had survived at higher rates, that the plague had, in effect, selected for it. They found 4 such variants, all in or near genes involved in the immune system, 4 positions in the human genome where the frequency shifted measurably in the decades after the Black Death, as if the population had been pushed through a filter. The statistical signal was strong enough to be called one of the most powerful evolutionary pressures ever documented in the human species. Not over thousands of years, as evolutionary change is usually imagined to occur, but within a few decades. The plague was so lethal and so widespread that it was able to reshape the genetic composition of entire populations in the space of a few generations. One of these 4 variants deserves particular attention. It sits in the DNA near a gene called ERAP2. The ERAP2 gene encodes a protein, a molecular machine, whose job is to trim fragments of foreign material down to the right size for presentation to the immune system's recognition cells. To understand why this matters, you need to understand a little about how the immune system identifies threats. When a cell in your body is infected by a bacterium, it doesn't just sit there passively. It does something active and quite clever. It takes fragments of the bacterial proteins inside it, cuts them into short pieces, and displays them on its outer surface, like a distress flag. These displayed fragments are then scanned by specialized immune cells called T cells, white blood cells whose job is to recognize foreign fragments and trigger a targeted immune response. The whole system depends on the fragments being the right size. Too long, and the T cell can't read them properly. Too short, and there's nothing to read at all. The protein encoded by ERAP2 is one of the enzymes responsible for trimming these fragments to the correct length. A molecular pair of scissors working inside the cell. The variant that became more common after the Black Death appears to produce a version of this protein that is better at processing fragments of Yersinia pestis. People who carry 2 copies of this variant, one inherited from each parent, were found to be approximately 40% more likely to survive the plague than people who carried none. 40%. In the context of a disease that was killing half the people it touched, a 40% survival advantage is enormous. It is the difference, in population terms, between a lineage that continues and one that ends. And so, over the decades following the Black Death, this variant became more common, not because anyone chose it, not because of any conscious process, but simply because the people who carried it were more likely to survive and reproduce, and their children carried it too, and gradually the proportion of the population carrying it rose. This is evolution, working not over geological time, but over human time, working fast enough that we can measure it directly by comparing the DNA of people who died before the plague with the DNA of people who died after it. Now for the counterintuitive part, the part that, once you understand it, changes how you think about the relationship between the immune system and disease. That same ERAP2 variant, the one that made people 40% more likely to survive the Black Death, is now associated with elevated susceptibility to autoimmune diseases, specifically conditions including Crohn's disease, rheumatoid arthritis, and lupus. These are all conditions in which the immune system attacks the body's own tissues. In Crohn's disease, it attacks the lining of the gut. In rheumatoid arthritis, it attacks the membranes around the joints. In lupus, it can attack almost any tissue in the body, the skin, the kidneys, the heart. All 3 are painful, chronic, and in some cases life-shortening conditions. And all 3 are more common in people who carry the variant that helped their ancestors survive the plague. Why would this be? The mechanism becomes clearer when you think about what the variant actually does. It produces a version of the ERAP2 protein that is more aggressive, better at processing and presenting fragments to the immune system, more likely to trigger a strong immune response when foreign material is detected. In a world where Yersinia pestis is present, this aggressiveness is life-saving. The immune system recognizes the bacterium faster, mounts a stronger response, and has a better chance of winning the fight before the bacteria overwhelm the lymph nodes. But in a world without plague, the world in which most of us now live, that same aggressiveness becomes a liability. The immune system, primed to respond strongly to anything that looks foreign, occasionally misidentifies the body's own proteins as threats. The molecular scissors cut fragments too aggressively. The T cells see distress signals in places where there are none. The immune system fires at itself. This is the cost of the adaptation, the biological price paid across generations for the survival advantage that the Black Death imposed. The people who survived passed on a gift, a stronger immune response that came wrapped around a vulnerability their descendants would carry for centuries, perhaps indefinitely, in a world where the original threat has largely been contained. Evolution does not optimize toward health. It does not design organisms to be well. It pushes populations toward whatever survives the present moment, regardless of what the future holds. The ERAP2 variant was, in the 14th century, an excellent solution to an immediate problem. It is, in the 21st century, a partial explanation for why some people's immune systems turn against them. We are, in a very literal and measurable sense, the descendants of plague survivors. The immunity they carried is written into some of us, and so, in a quieter way, is the cost of it. The Black Death did not end, not cleanly, not all at once. After the first great wave of 1347 to 1353, the plague retreated but did not disappear. It came back in 1361, in what contemporaries called the pestis secunda, the second plague, which was particularly lethal to children, those too young to have been born during the first wave and therefore carrying none of whatever partial immunity the survivors had developed. It came back again in 1369 and again in 1374 and continued to return in waves of varying intensity for the next 3.5 centuries. The last major outbreak in Western Europe struck Marseille in 1720, killing half the city's population. The plague years, in the broadest sense, were not 7 years but nearly 400. And then there was what historians call the third pandemic. In 1865, in the Yunnan province of southern China, a new wave of plague began. It spread slowly at first, moving into the Chinese interior, then reaching the coast. In 1894, it arrived in Hong Kong, and the world had changed enough by then that what happened next was different from anything that had come before. Steamships crossed the Pacific and the Indian Ocean in weeks rather than months. Rats traveled with them. And within a decade, the disease had reached port cities on every inhabited continent: Bombay, San Francisco, Sydney, Cape Town, Buenos Aires. It was during this third pandemic in Hong Kong in 1894 that a Swiss-French physician named Alexandre Yersin, working with the Institut Pasteur, first identified the bacterium responsible. He grew it in culture, confirmed that it caused plague in laboratory animals, and established what had killed tens of millions of people across 7 centuries. The bacterium was named after him, Yersinia pestis. In the same year, a Japanese bacteriologist named Kitasato Shibasaburo independently made a similar identification, and the two men's findings were published within weeks of each other. One of those moments in scientific history where the same discovery arrives twice, because the time for it has finally come. 4 years later, in 1898, a French physician named Paul Louis Simond demonstrated the transmission mechanism: the flea, the rat, the bite. He placed healthy rats in a cage suspended above a cage of plague, infected rats so that no direct contact was possible, and watched the healthy rats develop plague, transmitted by fleas that had crawled up the cage walls. It was an elegant and quiet experiment, and it answered a question that had haunted medicine for 500 years. Today, Yersinia pestis has not gone away. Between 1,000 and 2,000 cases are reported to the World Health Organization each year. The disease is endemic, meaning it circulates continuously in animal populations in parts of Madagascar, the Democratic Republic of Congo, and Peru. In the western United States, it persists in populations of prairie dogs, ground squirrels, and other rodents across a broad swath of the American West, from California to Colorado. Humans are occasionally infected through contact with wild animals or their fleas. A handful of cases are reported in the United States each year, mostly in rural areas of New Mexico, Arizona, and Colorado. The difference between these cases and the 14th century is a word: antibiotics. Yersinia pestis is susceptible to several antibiotics that were developed in the 20th century. Gentamicin, which works by binding to the bacterium's cellular machinery for making proteins and disrupting it, causing the bacterium to produce defective proteins and eventually die. Ciprofloxacin, a member of the fluoroquinolone class of antibiotics, which works by blocking the enzymes the bacterium uses to copy and repair its DNA. Without that repair mechanism, the bacterium's DNA accumulates damage until the cell can no longer function. Given early, within the first 24 hours of symptoms, these antibiotics are highly effective. The disease that killed half the people it touched in the 14th century can now, in most cases, be cured within a week. The key phrase is given early. The bacterium still moves quickly inside the body. The window for effective treatment is real and finite, and in parts of the world where access to medical care is limited, plague still kills. And then, in September of 2025, something quietly significant happened. Researchers at Tel Aviv University and Israel's Biological Research Institute published findings in the journal Advanced Science describing the first mRNA-based vaccine ever developed against a bacterial pathogen. mRNA vaccines, the technology that became widely known during the COVID-19 pandemic, work by delivering a small piece of genetic code into the body's cells. The cells read that code and use it to produce a fragment of the target pathogen's protein. The immune system sees that fragment, recognizes it as foreign, and builds a response to it. A library of immune cells trained to recognize and attack the real pathogen if it ever arrives. The code itself does not persist in the body. It does the job of training the immune system and then degrades. Until 2025, this technology had only been applied to viruses. Bacteria are different from viruses in important ways, larger, more complex, with different surface proteins and different mechanisms of infection, and it was not obvious that the same approach would work. The vaccine produced strong immunity against multiple strains of Yersinia pestis, including strains that had been made resistant to antibiotics in the laboratory. In a world where antibiotic resistance is a growing concern across many bacterial diseases, a vaccine that bypasses the need for antibiotics entirely is a significant development. There is something gently circular about this. The mRNA vaccine technology that the world came to know during one pandemic is now being turned toward the bacterium responsible for another pandemic 7 centuries earlier. The thread connecting them is long, but it is a single thread. Across that long thread, what has the plague left behind? It left its mark in the language. The word quarantine, as we have seen, came from the Italian for 40, the 40 days that ships were made to wait in Ragusa's harbour. The word plague itself, in most European languages, became a synonym for any catastrophic spread of disease, and then beyond that, for any overwhelming affliction. We speak of being plagued by doubts, by problems, by things that will not leave us alone. The word carries the memory of something that would not go away. It left its mark in the landscape, the deserted medieval villages of England, the empty plots in the centres of German towns where Jewish communities once lived. The Great Plague Pits, some of them only recently located by archaeologists beneath the foundations of later buildings. A pit discovered beneath a London construction site in the 1980s, containing the remains of hundreds of people buried in layers, the burials becoming less careful as the crisis deepened, as the capacity for individual graves gave way to the necessity of mass ones. It left its mark in the arts, in the Danse Macabre tradition that ran through European painting and sculpture for 2 centuries after the first wave, in the particular quality of late medieval and early Renaissance religious art, more emotionally intense, more focused on suffering, more willing to look directly at the body in pain, that some art historians trace, at least in part, to the experience of having watched so many bodies fail. And it left its mark in the genome, in the immune system variants that became more common in the post-plague population, in the elevated rates of certain autoimmune conditions that may be, in part, the distant echo of a selection event that happened 700 years ago. We carry the plague's passage in our cells, in the particular way our immune systems are tuned, in the ancient conversation between a bacterium and the bodies that learned, at great cost, to resist it. The people of the 14th century had no name for what was happening to them. They called it the Great Mortality, the Pestilence, the Plague of Florence or the Plague of Siena. The name Black Death, La Mort Noire, came later, applied retrospectively by people trying to name something that had seemed, while it was happening, almost too large to name. Those people woke in the morning and did not know if they would be alive by evening. They buried their children with their own hands. They left bread on doorsteps and kept working and kept praying and kept going in the way that people do when there is nothing else to do but keep going. And the world continued. The fields were replanted slowly. The mills were repaired. New priests were ordained to fill the empty parishes. Children were born into the quieter decades after the worst of the dying, and those children grew up in a world that was different from the one their grandparents had known, a world with more space in it, more possibility, more leverage for the ordinary person against the structures that had bound them. The transformation was painful and incomplete and uneven, and it came at a cost that no one would have chosen to pay. Europe's population would not return to its pre-plague levels for 200 years, and yet it did return. The thread held. It was thinner for a long time, and it was frayed in places where it had been cut, and the people who held it were not always aware of how much weight it had already carried, but it held. You are here tonight, in this quiet room, in this particular moment, in part because of that. Because somewhere in the long chain of people who eventually became you, there were people who survived. Who had, perhaps, the right variant near the ERAP2 gene, or who happened not to be bitten by the right flea, or who lived far enough from the trade routes that the disease passed them by, or who simply, somehow, held on. Their survival is encoded in you, not as memory, not as knowledge, but as biology. As the particular shape of your immune system, as the small, patient machinery inside your cells that has been refining itself through exactly this kind of pressure for longer than any of us can quite imagine. The night is old now. The story has traveled a long way, from a mountain cemetery in Kyrgyzstan to a harbor in Sicily, from the lymph nodes of a 14th century body to the DNA of a modern one. From the death carts moving through the streets of Siena to a laboratory in Tel Aviv and a quiet discovery about mRNA and bacterial immunity. It is a long story, and it is not finished because these things never quite finish. They settle into the background. They become part of the geology of human experience, the deep layer beneath the surface of the present. The people who lived through the plague years endured something almost beyond imagining, and the world continued, and we are their survivors, in the most literal and biological sense of that word. Let that settle into you if it wants to, or let it go. The night will hold it either way. You have been still for a long time now. The day is a long way behind you. Whatever you were carrying when you lay down tonight, whatever weight the hours had left in you, you have been setting it down slowly through all of this. You don't need to pick it back up tonight. It will wait. The bacterium is still out there, in the burrows of prairie dogs and the soils of Madagascar, patient and ancient and entirely indifferent as it has always been. And the immune system is still there too, inside you, doing its quiet work, trimmed and shaped by 700 years of exactly this kind of conversation between threat and response. You are the result of an enormous amount of surviving. Drift now, if you're ready. Sleep well.